Again, welcome to Python programming language. In these lectures, we're going to cover stacks, queues, and priority queue data structures. These lectures cover chapter 18 of our course textbook. So again, stack, queue, and priority queue, they are the same as linked list data structures. We implement them using object-oriented programming concepts. So we are going to create a class named stack, queue, and priority queue. And as we all know, every class have its own data members, which is the properties of the class, and also its methods, which are the behavior. So in this, our main objective is to cover design and implementation stacks, queue, and priority queue. So first, we start with what is a collections. Here we say a collection is an object that holds and organizes other objects. Also, it provides operation for accessing and manages its elements. So this means data structures such as stack, queue, priority queue, and linked lists are collections because they are objects that organize and holds other objects, which will be their elements. And also they have their own methods they can use to again manipulate their elements. So many standard collections have been defined over time. Some collections are linear in nature, others are non-linear. So here we are dealing with linear in nature. Stack queue and also priority queue are linear collections or data structures. Non-linear data structure can be trees and also graphs, which we will discuss that in our future lectures. So these are linear and non-linear collections. We have, again, trees and graphs are non-linear, stack queue, linked lists, priority queues, they are linear data structures or collections. So next, what is a data structure? Again, we said a data structure is a collection of data organized in some function. So a data structure not only store data, but also it supports the operations for manipulating the data in the structure. So for example, an array is a data structure that holds a collection of data in sequential order. So array is a linear data structure. You can find the size of an array. You can also store data in an array. We can retrieve data and also modify data in an array. So array is a simple and easy to use, but it has two limitations. First, we know array is again a static data structure, which means anytime we create an array, we have to specify the size of the array. We cannot increase the size while the program is running. So it's not a dynamic implementation. It's a static. We can only change the size of the array when the program is not running. So this leads us to what is an object-oriented data structure. Most of all the data structure we are covering here is implemented using object-oriented concepts. So in object-oriented thinking, a data structure is an object that stores other objects and referred to as a data or element. That is the object that it stores. So some people refer data structure as a container or a collection object, as we said earlier. Now, to define a data structure is essentially to declare a class. So first we need to declare a class named stack. Then from the class, we can create stack objects. So a class for data structure should use the data fields to store data and also provide method to support the operations such as insertion and deletion. Now, to create a data structure is therefore to create an instance from the class. You can then apply the methods on the instance to manipulate the data structure, such as inserting an element to the data structure or deleting an element from the data structure. This concept, we already cover it in our textbook, chapter 9 and 10, when we discuss object-oriented programming concept. So the four classical data structures again are the linked list, stack, queue, and priority. And here we're going to cover stack. In our previous lecture, we covered a list and linked list. So a stack can be perceived as a special type of list where the insertion and deletion take place only at one end. That end we refer to as the top of the stack. Also, a queue represents a waiting list. So a queue may have the back and the front. We insert data into a queue through the back or the rear of the queue, and we remove data from the front of the queue. And sometimes we may refer to the rear of the queue as a tail. And then we may refer the front as the head of the queue. A priority queue also uses the concept of queue, but only elements that have the highest priority will be removed first or will come out first. And we may go details on this. So this is the limitation of array again. Once an array is created, its size cannot be altered during when the program is running. Also, array provide inadequate support for inserting, deleting, sorting, and searching operations. So let's start with stack. Now we say a stack again is a classical collection used to help solve many types of problems. So a stack is a linear collection or a linear data structure whose elements are added in the last in, first out manner, which means the last item that was added to the stack will be the first item to come out. So we should think of stack as a stack of books where you add and remove from the top, but you cannot reach into the middle or the bottom. So this example, we have a stack of coins, stack of trays, stack of boxes, and also stack of books. We can only add and remove books from the top of the stack. In this case, apply math. If I want to remove chemistry, then I need to remove apply math first, word history, Java programming, English, then I can remove chemistry. So this is the stack conceptual view. Top of the stack, that's where we can add elements. And also at the top of the stack, we can remove an element. So let's see the example here. The first, we have an empty stack. We push data 1 in. So right now we have data 1. We push data 2, so we have 2 items. We push data 3, we have 3 items. Now, if we want to pop item out, data 3 have to be popped first. Even if I want to pop data 2, we need to remove 3 first before we remove 2, and then we can remove the 1. So the adding or pushing an item into a stack and removing an item from the stack always take place at the top of the stack. So some collections use particular terms for their operations. In this lectures, we are going to use the term push. Push means we add an element to the top of the stack. Pop means we remove an element from the top of the stack. Pick means we are going to examine the element at the top of the stack, but we are not going to remove it. It's empty is to check if the stack is empty. We also have a size. Size will determine the number of elements in the stack. So stack can be used for postfix expression checking. So let's see how a stack can be used to help us solve a problem of evaluating a postfix expression. A postfix expression is normally written with the operator following the 2 operands. So example, instead of saying 15 minus 8, we say 15, 8 minus. This is a postfix expression. Always the operands come first before the operator. Traditionally, we call our arithmetic expression as infix expression, which means the operator is between the 2 operands. Now, we have an expression here, postfix expression, 3, 4 times 2, 5 plus minus 4 times 2 divide. This is the same as the infix expression here. So normally, we can check if this is correct or wrong. Now, by looking at it, we start with the inner parenthesis. 2 plus 5 is 7. We have parentheses for this, so this is correct. Now, we are going to use a stack to check if the postfix expression here is correct. So this is how it works. We are going to scan the expression from left to right. Now, anytime we encounter an operand, we are going to push it into the stack. Then anytime we encounter an operator, we are going to pop 2 items out, because addition, we need 2 operands. Multiplication, division, the same. Then here we can check. At the end, if we don't, the stack is empty, means it's correct. Now, if we end up with 1 operator or 1 operand left, then the expression is wrong. So again, this is the algorithm to evaluate postfix expression using stack. Scan the expression from left to right. When we get an operand, we push it into the stack. When we get an operator, we pop 2 items from the stack. We perform this operation over until we finish. So let's see our example here. We want to evaluate if this postfix expression is correct. So the first thing, we have 7, we push it in. We came with 4, we push it in. We have -3, we push again. Now next we have multiplication. Since we have multiplication, we pop the 2 operands and did the multiplication. So 4 times -3 will give me -12. Next we have 1, we push 1. 5, we push 5. Then we have a plus. So since we have a plus, we pop 2 items and do the addition. So 5 plus 1 is 6. Next we have a division. Since we have division, we pop 2 items out. So -2 divided by 6 will give me -2. I'm sorry, -12 divided by 6 will give me -2. Then the last, we have a product. Then we pop 2 items out. Now here we have 2 operands, so this expression is correct. So our final solution here will be 7 times -2. That will give us -14. So the expression is correct. Now let's see the stack class and also implementing it in a Python language. So this is our stack class name. The second row is the data members. Here we need only the list, the elements that we are going to store in. Then we have the stack constructor. We have a method to check if the stack is empty. We also have a method to pick what is on top of the stack. We have a method to push an item into the stack. We have a method to pop an item from the stack. And we have a method to check the number of elements in the stack, which is get size. So this is our, again, designing of the class stack. Now let's see the implementation in Python. So here we can see the keyword class. The name of the class is stack. We have our special initializing method. Then here we have only 1 data member, which is elements. And this element will be array. Now we have our first method is empty. This method will check if the stack is empty. So here we say that if the length element is equal to 0, that means the stack is empty. So if this is true, that means the stack is empty. We are checking if the element in the stack is equal to 0, where the length. Now we know that in Python, len will give us the number of items in an array. The element here, we implement it as array or list. Now next, we have a method to pick what is on top of the stack. So the first thing we do, we don't want to pick an empty stack. So we check if the stack is empty. If it's empty and it's true, we return none because there's nothing to pick. Otherwise, we are going to return the len. So if the number of items in the stack is 10, len self.element will give me 10. So it will be 10 minus 1. So the index will be 10 minus 1 because from 0 to 9 is 10. So here we are going to return the top. Now next is to push an item into the stack. So here we are using the method append. Remember, append comes with the list data structure or the list array. So append means we are going to add an item to the end of the list. So we can use it to add an item to the top of the stack. Now pop we want to remove. So first we check, we don't want to remove an item from empty stack. So we check first if the stack is empty. If the stack is empty, return none. Otherwise, we call the method pop to remove the item from the stack. Remember again, the pop is a built-in method already for us in Python list. Then next we get a size. The size, we can use the length built-in method len. So again, this is the class stack. First, we have our initializer. We have a method to check if the stack is empty. So all we need, use the len method and check if element equal to 0. Next, we pick. First of all, we check if the stack is empty. If it's empty, we cannot pick anything, so we return none. Otherwise, we will return the last index. So the length will give me the number of items. The index will be from 0 to 9 because again, here we are using array or list implementation. Next, we want to push an item. So we just use the method append. Remember, element is more or less an object for us here. So the same thing, we can pop an item. To pop first, check if the stack is empty. If it's empty, return none. Otherwise, pop one item. Again, the item will be popped from the top. Now, let's see that our next test stack. Here, we are going to create a stack object. First, this is object-oriented programming. So we import our stack class first. Then we create a stack object named stack, but start with the lowercase s. Python is case sensitive, so the class name start with uppercase s. The stack object lowercase s means they are different. Now here we want to push an item into the stack, which we want to push from 0 to 9. So we say for I in range 10, push I. So the first I will be 0, 1, 2, up to 9. When we reach 10, the loop will stop. After we push 0 to 9, here we say, why not the stack is not empty? We should print and pop. So when we run this program, it's going to print numbers, but instead of printing 0, 1, 2, 3 up to 9, it's going to print 9, 8, 0, because remember, we push from 0 to 9. So 9 will be at the top of the stack. Then we pop in the reverse. So that's why we always say stack also is very good to use if you want to reverse a list of items. You can just push all the item into a stack, then remove all of them, and you get the reverse of it. So next we move to a queue. A queue also is a data structure in which the elements are added at the rear and also removed from the front. So a queue will be first in, first out. Example given here, a queue, let's say a queue in a supermarket or a library. The front of the queue will come out. If you want to join the queue, you join from the rear. So that's the main difference between stack and queue. Stack have only one entry and exit from the top, but queue have the front for exit, the back for entry. Example of a queue can be used in an operating system. So operating systems often maintain a queue of processes because they have to, or even a network system printing, we want to print the first item that come to the queue. So we can use queue operation for network printing system. So again, computer system must often provide a holding area for the messages between the two processes. So two programs or even two systems. This holding area is equally called a buffer, and it's often implemented as a queue also. So the first item that get in will be the first item to come out. Also, our software queues have a counterpart in a real world queue. For example, we wait in queue to buy pizza, to enter a movie theater, and to drive on a turnpike, etc. So this example of a queue, first we put a data, we have empty queue. So from the rear, we assuming the rear is the top and the bottom is the front. So we put data 1, we put data 2, we put data 3. Now To remove, data 1 will come out first. Then data 2 will come out, data 3 will come out. Next is the design of the Q class. Again, we have the class name will be Q, starting with uppercase Q. We're also going to implement it using linked list, the elements. We have our Q constructor to create an empty Q. And Q will be to add an element to the Q. Then the Q will be to delete an element from the Q. We also have a get size method to give us the number of items in the queue. We can also check if the queue is empty. And here we have a special string method that basically returns the string representation of the queue object. So the operation again, we have constructor to initialize, enqueue to insert an item from the rear of the queue, dequeue to remove an item from the front of the queue, get size will tell us number of elements in the queue, and it's empty, check if the queue is empty. Now, since get size, we can use the len method. We don't need to include, let's say, a variable name size, so that whenever we insert an item, we increment the size. When we remove an item, we decrement the size. We don't need it because the len method can give us the size. So let's see the implementation in Python. So here the queue, we are going to use the linked list. So first we import our linked list into the queue class. We have our special initializer to initialize our elements using linked list. Previously in the stack, we use list, more or less an array. So here we have the method to insert an item into the queue. So we know we have a built-in method named add that can add an element, so that will add it. The queue is to remove. So first, before we remove an element from a queue, we want to check if there is anything inside the queue. If the queue is empty, then we return none. If there is at least one item, then we are going to use remove at. You can see remove at 0. So we have to remove the first element. Q again is first in, first out. Next, we have the method to get size. It's the same as stack. We can use get size. Then we also have the special string method that will return the string representation of the queue object. Then we also have a method to check if the queue is empty. So now let's see our main method implementation. So first we have to import our queue again class. So we create our queue object starting with lowercase q. So as we have this object can use any of the method in the queue class. So here we have enqueue to insert an item into the queue that we create queue.enqueueTom. Then we print it. Next we insert John. We print it. Then next we also insert George. And then we also insert Michael, and then we print. Now we remove elements. So when we say q.dequeue, we are going to remove the first item, Tom. So we'll print Tom. Then the next item will be John. And then we print the rest of the item in the queue. So that's the whole example of a queue. Now let's go to the next data structure, which is again more or less same as queue, but this is called a priority queue. So priority queue also is the same thing as first in, first out. So we should record that first in, first out queue remove element in the order in which they were added. But priority queue will remove elements in a priority order. So the element that have highest priority will be in the front, even if they come last and their priority is higher, they will be in the front. So priority queue are helpful in many schedule situations, especially in the operating system also. And we normally use what we call the heap. A heap is a classical mechanism for implementing the priority queue. We will discuss about heap sorting, heap concept in trees also. Now, a regular queue is a first in, first out data structure. Elements are appended at the end of the queue and are removed from the beginning of the queue. But with priority queue, elements are assigned with priorities. So when accessing elements, the element with the highest priority, as we said earlier, is removed first. So a priority queue has the largest in, first out method. So for example, emergency room in a hospital will assign patients with priority numbers based on the type of sickness they have or disease. If their condition is very deadly, very serious, they may get the highest priority to be treated first. So this is the class for priority queue. We have the heap. We have to use the concept of heap. Then we have the NQ and DQ and get size. That's NQ is in add element to the queue. The queue is to remove element, and get size to tell us the size of the queue. So here we have again, in this case, as we said, the heap, we are going to discuss the heap in our next lectures when we cover sorting. So here you can see that in priority queue, we implement the heap. So we import it, and then we create the heap element using the heap constructor. Then we can do our NQ. So we say imp.add, same thing as we did in queue. So the heap again will do the implementation of the priorities of each element. So everything is the same. And so the queue also the same thing. First, we have to check if the queue is empty. If it's not empty, then we use the remove method to remove. We can also get the size using the get size method. Now let's see example of the test. So here we can see again, from priority queue, we import the priority queue. So we can create as now this is the concept of heap. So you can see that each data have its own priority. So Cindy is 7, priority 5, etc. So here we create our priority queue, which we call it priority queue, but start with lowercase p. So it's different from the class name. Then we insert the 3 patients, the 4 patients here. Now we say why the priority queue dot get size is greater than 0. We want to remove. Now, when we run this program, we will see that the patients with the highest priority will be removed first. Here we are assuming this is where we insert patient 1. So patient 1 went in first. Most likely patient 1 will not come out first because since they didn't have the highest priority, then it will come out first. If it's based on the highest number is the priority, highest priority, or the lower number is the lower priority, then Jim will come out first. So that will be the conclusion of these lectures. Again, in these lectures, we cover the concept of stack, queue, and priority queue. We saw the design of each classes and also in the implementation of it using Python. And again, we're going to have a lab lectures, which will be hands-on lectures on this topic in the future lectures. Thank you.